Welcome back, students. In this part 7, we are going to solve exercises about the transitive property and other properties that we learned earlier. Let's start with exercise 1. In the figure above, segment AB equals segment CD. So this is a straightforward evidence given. And the points A, B, C, and D are collinear points, so these 4 points are located on the same line. Show that segment AC equals segment BD. So AC equals BD question mark. So here we don't have any measurements given, so I cannot prove that these two segments are equal by calculation, so I need to use another method. Here if we notice, segment AC is formed by AB and by BC. Same for segment BD, it's formed by segment BC and CD. So we notice that segment BC is a common side of both segments AC and BD. We can also claim, since these 4 points are collinear, the fact that segment AC is the sum of AB plus BC, this green segment plus this pink segment BC. Also, segment BD equals to segment BC plus CD. It's the sum of these two segments. So let's write first these two equations. AC is equal to segment AB plus BC, segment addition. I can only use segment addition if the points are collinear. If, for example, BC is drawn in this direction, I cannot claim this equation, so be careful. Also, I can claim that segment BD is equal to segment BC plus CD, also segment addition. Now, to prove that segment AC equals segment BD, we need to prove that the two quantities AB plus BC and BC plus CD are equal. So here, in fact, we have the sum of two segments. Let's prove that these two sums are equal. But here we notice that segment BC is equal to segment BC because it's a common side of both segments, AC and BD. Also, we can claim that segment AB equals segment CD. It's given. It's a straightforward evidence. So since AB equals CD and BC equals BC, we can claim that these two sums, these two quantities, are obviously equal. And the result, AC equals BD by transitivity, because both segments are equal to the same quantity. Result, AC equals BD by transitivity. So here if we notice that the two quantities that we are proving that they are equal are in fact the sum of two segments. And to prove that these two sums are equal, we need to prove that each element of these two sums are equal to the elements of the other sum. Now exercise 2. In the figure above, we have the 5 points E, F, G, H, and T are collinear points. And here we also have these two straightforward evidence, the fact that segment EF equals segment HT and segment EG equals segment GT, so it's given. Show that segment FG equals segment GT question mark. So here, if we notice also we have no measurements given, so let's try and use the transitive property by using the given information written in the exercise. So here, since we know that these two segments are equal and that these two segments are equal, let's see what is the relationship between segment FG and the other two segments EF and EG. So here we notice that FG is a part of segment EG. So FG is in fact equal to EG minus EF, segment subtraction. Same here, we notice that segment GH is a part of the segment GT. So GH is equal segment GT minus segment HT. So let's write these two information that we just noticed. FG equals segment EG minus EF, segment subtraction, and segment GH is equal to segment GT minus segment HT, also segment subtraction. Now we need to prove that the two quantities EG minus EF and GT minus HT are equal. If we prove that these two difference of two segments are equal, in this case we proved that these two segments are equal by transitivity. So here we notice that EG equals GT because it's given, it's a straightforward evidence, and also EF equals HT, it's also given, it's a straightforward evidence. So result, these two segments are equal by transitivity. So let's write EF equals HT, it's given information, and also EG equals GT, it's also given information, so I write given as reason, it's a straightforward evidence. Result, segment FG equals segment GH by transitivity. So here these two exercises are very important. In the first one, when we prove that these two quantities are equal, for example, if AB was equal to 2 centimeters, so CD is also 2. For example, B 3 centimeters and BC 3 centimeters, 2 plus 3 and 3 plus 2 are equal to 5. So we proved here that these two segments are equal without having any measurements. Same here. For example, if EG was equal to 7 centimeters and EF was equal to 4, since we know that these two segments are equal and these two are equal, it will be here like we have 7 minus 4, 3. So we proved here that they are equal without having any measurements by using the transitive property. So it's very important to know how to prove that two segments are equal in some cases without having any given measurements. Exercise number 3. So it's very important, so be careful to all the details that I will mention. In the figure below we have ABCD is a rectangle. This is the first information given. And angle EBM equals angle FDN equals 90 degrees. And also we have a third information, the fact that triangle BME and triangle DNF are congruent triangles. It's given information, I don't have to prove it. Show that segment AN equals segment CM question mark. In this exercise also, we don't have any measurement given to us, so I cannot prove that these two segments are equal by calculation. So I need to think of another method. Let's try here using the transitive property also. Here, can I use this property? Are these 3 points collinear? To claim that AN is equal to AD plus DN, and to claim that segment CM is equal to segment CB plus BM? Yes, we can, because these two angles are right angles, and also this angle and this angle are right angles because they represent the angles of a rectangle which are equal to 90 degrees each. So this is in fact a straight angle because 90 plus 90 equals 180 degrees, and same, these two angles are straight angles, and as a result this is a straight line, and the 3 points are collinear, same. This is straight angle and the 3 points are collinear. Now, having the fact that segment AN equals AD plus DN and segment CM equals CB plus BM, we need to prove that these two sums are equal. Here we notice that segment AD and segment BC are equal because they represent the opposite sides of a rectangle, which are equal. We deduced it from the property of a rectangle that is given. And can we claim that dn equals bm? So here, the fact that the two triangles BME and DNF are congruent, we can claim that all their corresponding elements must be equal. In particular, or namely, we can claim that dn equals bm. So yes, they are equal because they are corresponding elements of the two congruent triangles BME and DNF. So let's start with the proof. Segment AN equals AD plus DN, segment addition. Segment CM equals segment CB plus segment BM, also segment addition. We need to prove that the two sums, the two quantities AD plus DN and CB plus BM are equal. We already proved that AD equals CB. It's not straightforward evidence like in previous exercises. No, we use the property of the opposite sides of a rectangle are equal. That's why they are equal. We need to write the correct reason. And also DN equals BM because they represent two corresponding elements of these two congruent triangles that is given to us. Corresponding elements of congruent triangles BME and DNF must be equal, and as a result, segment AN equals segment CM by transitivity. This is the end of our video part 7. I would like you to redo these exercises on your own after watching the video. We still have only one part, part 8, that will be uploaded tomorrow, and then we are going to solve the exercises in our book. And in the end, I would like to thank you for watching.